Okay, everybody, 1 second. I'm getting connected and we'll get started in just 1 minute. Okay, so why don't we get started, everybody? Welcome to our second day of class. Hopefully you had some success getting Python installed on your laptops. So we will be working with that today. And again, it looks like we have kind of an even split between in person and on Zoom. So I will request that the TAs help me monitor the Zoom because I may not notice what's going on. So that would be great. Okay, but to get started, so I'm actually going to open up the lecture 2 materials in the Jupyter Notebook. We'll go over this a little bit more in a bit. But one way that I can do that is by launching Anaconda. Okay, and then I can open Jupyter Notebook. Okay, and so then notice this opens up in the browser and I can navigate to whatever folder I have my Jupyter Notebooks in, and I can run it that way. So let me find today's lecture, our intro to Python. Okay, we're going to start off today actually talking a little bit about command line interfaces before we go into Python and Jupyter Notebooks. So this will just be a helpful background. Yes.
Sorry to interrupt, but can you share your screen? I can't see it on Zoom.
Oh, yes, I'm so sorry. Thank you. Okay, hold on. I knew I was going to forget something trying to do both. Okay, can my Zoom people see? Okay.
Yeah, we can see it.
Thank you. Okay. So let me zoom in here a little bit. Okay, so first of all, what is a command line interface? That's just a way of interacting with your computer other than a graphical interface. These days, usually we just open up applications and click on things, but actually more powerfully is to manipulate things via the command line or a terminal. Well, I guess sometimes easier, sometimes harder, but it's good to be familiar with some of the basics here. Okay, and so there are different types of command line interfaces. If you are using Windows, there are certain Microsoft command line interfaces, MS-DOS famously, more recently PowerShell. And then there are Unix-based interfaces, Linux and Mac. And that's what we will discuss. We'll be discussing the Unix-based interface as these are really becoming dominant. Okay, but remember, if you are on Windows, you don't really need to do stuff in the terminal. You're fine to, start Anaconda and launch it from there. If you're on a Mac, you can do it either way. Okay. All right, so let's get started. So first of all, I'm just going to launch a little command line window here. So I'm going to go to my terminal and start a new terminal window. Okay, and so now you'll notice what's going on. Let me see if I can get this out of the way. There we go. Okay. Feel like I don't have enough screen space. Okay, so when you open up your terminal, what do you notice? You'll see your username, right? For me, that's little. And then this little sign there, the little tilde, indicates that I'm in my home directory. And then you'll have some kind of symbol indicating that, you know, this is like a command line prompt. So for me, it's the % sign, but it could be a $sign depending on your setup. Okay. So let's see. So some, and yeah, could be also like a little greater than symbol too. And most of what you're doing in the command line is, you know, running little applications or commands. So one thing that we can do is go into a folder and list all of the files in the folder. So as I mentioned, I'm in my home directory. If you don't know where you are, you can always do pwd to see where you are. And then I'm going to navigate into the folder where the lectures are. I think it's, yeah. So, okay, great. So now I'm inside, I just navigated inside the folder where the lecture materials are. And if I do an ls command, I can see, is that, it's a little small to read, I guess. Hopefully we can see that. Wonder if I should change the default. I can see all of the files that are listed inside that folder. Okay. So if you want more detail, you can always follow the ls command with a -l. And this will not only list the file names, but will also tell you the date, how big they are, certain permissions on there, etc. Okay. So what's really, really important when you're working in the command line is to understand that everything on your computer is stored in a hierarchical structure. So it really matters where you are, what folder you're in when you run commands. And you can like navigate into subfolders using this little / symbol. And you're going to get this like tree structure. Okay, so for example, we can, sorry, that was loud. Maybe turn that on. So we can navigate with the change directory command as follows, like you see here. So this would start with your home directory and then navigate down into the homework, for example. Okay, and if I want to go up a directory, there's various shorthands that are helpful. Sorry, let me quit that. Okay, various shorthands that are helpful here. So 1 period stands for the current directory, and 2 periods stands for go up 1 level in the hierarchy. So for example, right now, recall I'm in the lecture 2 folder, right? And if I cd 2 dots, I'm going to go up 1 folder. And now where am I? I'm just in the lectures folder. Okay. So good. Another thing that I can do in the command line is I can make a new directory with the make directory command. So that would be mk, all one make directory, and I'm going to call it test directory. And so actually, let me go ahead and navigate into the, sorry, into my Python folder, into the Intro to Python lecture folder, and then make a new directory there. Okay, and so now if I list all the files, I can see that I've created a new thing, which is this test directory. It's empty, but it's a directory that I've made, and I can put stuff in it now if I want to. Okay, so another important command is the CP command, which is copy. And so I can copy, so the syntax here would be copy, okay, the file that you want to make a copy of, and then what do you want to call it, or where do you want it to go? If you could also move it somewhere else, but for example, I can, this new repo.png is an image that's in that folder, and I can make a copy of it. And now I can then move it. So now you'll see that it's showing up, that copy of the new repo copy.png. And now I can move it into the directory I just made with the mv command. Okay. Okay. And one really helpful thing when you're working in the command line is that the tab key auto completes. So if you can't remember the name of the folder you want to get to, but you can remember the first few letters, you start writing it and then hit tab and it'll attempt to auto complete. So that will save you a lot of time. Okay. Okay, so now I have moved that file into the folder, so I can also say list the files in test directory, and it will show me, it should show me
Sorry,
that.
Anna, your folder name test directory was typoed.
Oh,
Yeah, it was like test direct or something.
Yeah.
Okay. Thank you. I was really confused there. Okay, so if you can spell correctly, then it would be in there. Yeah. Yeah. Or should I just move it a little further away? Let's see. It is up really loud. I feel like it's a lot louder than last time.
It's just the Zoom.
I'm actually not 100% sure how to turn it down. I can turn it off. Can you guys hear me without it on? Is that better? Yes? Let's try this for now. And if people have trouble hearing, we'll turn it back on and I'll try to like move it away. Okay, so let's see, what did I do here? I had a typo when I made my thing. Oh, but anyway, that's fine. You get the idea. Okay, so you can also remove a file with the rm command. So rm will remove. If you're inside that folder, all you have to do is write the file name. If you're not inside the folder, just give the path leading to the file. You can remove a file. And if you want to remove a folder and all of its subfolders, you can do the rm-r command. Just be careful with that because that's going to delete everything in there. Okay. A couple other commands that may be helpful. I think I'm going to go just to my home folder now. If you do touch file.txt, that will just create a new file called file, text file. It's empty, but it just makes an empty text file. And you can also use the echo command to essentially like print words to the screen. So I can, darn it. 1 second. I'm not quite sure what I did, so let me start over. Okay, so we want to, yeah, let me do this again. Create our file. Okay, we can print something or just have it print out with the echo command, certain text. And another command that's useful is the cat command, the CAT, that will show you what's inside a file. So if I say cat, the file I just made, well, it was empty, so I don't see anything, but if we had actually put something in there, it would show us the contents of the text file. And then PWD stands for print working directory. That's super helpful. And the man CMD, sorry. Yes, we'll drop you into the man pages. So that will give you information if you want more information about a command. So if I do man ls, this will just bring up the manual, basically the help documentation on that command. So I can get, more information about how to use it. Okay. So another thing that's useful on the command line is something called piping. So for example, here, this little up-down bar is doing a piping. So the grep command is a little bit of a complicated command, but it's basically pattern matching. So it's saying, look inside my folder and find any file that contains the text IP, Y, and B. And then when you find all those files, you're feeding it into the ls command. So you're basically listing all of the files that match this pattern. So that's helpful. And so if you ran that, for example, inside the lecture folder, you should see all of the Python notebooks there, all of the Jupyter notebooks there for today's lecture. Okay. And then redirecting is similar. So redirecting you do with these little double arrows. You're passing the output of a command to a file. So if you say echo hello world, double arrow for redirecting, you're creating a new file, test.txt, text file that has hello world written in it. Okay. So let's see what else. So you can think about all these little commands that we're going over. They are like little programs, little things that little programs you can run in the terminal, but you can also run big programs in the terminal like Python or other similar things. And so, or Jupyter notebooks, as we will see soon. Okay. So one other thing to go over, I guess, in the command line before we move on to Python is Git. And so we wanted to expose you to Git and version control, but it's not, you actually won't have to do too much with that because we're not going to have you write to any of the Git repositories. All you need to do is clone them, pull them, and access the materials. So maybe you've already figured this out already, but if not, let me just kind of demonstrate how you would access all of these materials. So first, you just want to navigate to the directory that you want to put them. So where am I? I'm in my home directory. that's fine. I'm fine to make a folder in my home directory that contains all of the homeworks. So all I need to do once I'm in the folder where I want it to go is git clone and then put in the URL. Okay, and so you'll see, what did that do? If I go to my home directory, it just created that folder right now that has all of the homework in it. So that's actually was really easy, right? Just one command and it cloned that whole folder. Now, as we update the homeworks, you'll want to pull from the repository. And so to do that, you need to navigate in there. Okay, so go inside the folder. Now I'm inside the folder and I can do a get pull. And so when we post a new homework, you just go in and do a get pull and you'll get the new homework that's been posted now. Right now it's saying already up to date because I didn't change anything. But you should see something like this when you pull and there's been an update. Okay, any questions on anything so far? Yeah.
You have to install the Git extension and the Git timeline.
Well, yes, you do need like Git installed on your computer. Yes. I'm sorry, but I'm guessing that usually it is, but yeah, you want to double check. Yeah.
So when we do the Git pull, we must navigate into the directory.
That's right. Yeah.
So for Windows, I ended up just downloading the zip files to my computer directly
Okay,
because there's all sorts of issues trying to get help to work with it.
that could be.
So the best thing to do is just download the zip files and then put it in the same drive that you have your Anaconda in.
Okay,
And when you open Jupyter, then Jupyter will scan through your whole hard drive, and then you'll find the files.
right. So that's a great workaround.
Yeah.
Probably you'll just need to download the whole repository each time, but
Yeah,
that's fine. That won't be a big deal.
It's not terrible.
Yeah.
But until I can figure something else out, that's kind of weird.
No, that's good. Anybody else? Okay, so one thing I will say, I'll point out, we are using Git for posting the lectures and the homeworks. But one thing, because we're using Jupyter Notebooks, they don't work great with version control because of this kind of like browser-based format. It can't like integrate two different Jupyter Notebooks. It has trouble with that. So at the end of the day, if you download the repository and you make changes in one of the lecture files or one of the homework files, and then you do a git pull, you're going to get a conflict. So what I would recommend is before you like start playing with things, or for example, if you want to work on your homework, just rename the file, create a new file with your name on it, and then you can make changes and do your homework in there. And then when you do a git pull, you may see some updates, but it won't cause any conflict with what you're working on. Of course, if you've just downloaded it, then it's fine. You don't have to worry about that, about getting conflict. Okay. And also if you've made changes, but you don't want to keep them and you're fine if they get overridden, you can do this git checkout command that you see right here, but only if you're okay with it getting replaced. Okay, so that's a little background on command line stuff. And so now we're going to talk a little bit about Python. Okay, so basic Python.
Another thing on the command line, if you're in Windows, some of the commands you have to find the command version for Windows. For example, ls doesn't work. You have to use EIR, which is a directory.
Yeah.
Or copy is not you have to type coffee instead of the CP. So you have to go, if it has help in the command line in Windows, and it'll show you all the commands, in the command line.
Okay, great. Thank you for that.
Something again, hope doesn't work for Windows unless you find the
Yeah.
similar command.
Out of curiosity, how many people are running it in Windows?
Oh, well, I was gonna say about that. Anaconda actually has a workaround for that, because this was really annoying me to just look it up. You can get access to the Linux and like Unix commands if you open your Anaconda prompt, then you have conda install. I think it's like conda install into dash base, and then it'll install all the stuff you need to run Linux commands.
Okay, so if you may, maybe you can post that in Piazza if that would be helpful, because it sounds like we do have a large number of people who are running it in Windows. Okay,
Yes, you can let them post any question on Piazza because I'm using Windows and I can help them figure those things out.
oh,
yeah.
that's great. That volume is really high.
Sorry.
Oh, no, it's not your fault. I think it's the way I have.
I think you just have to turn the volume down to your volume.
Yeah, okay. I don't see the command for that because of.
I was gonna add for this for hours.
No, I don't want to mute it.
There are settings.
Okay, I'm actually I think because of, let me try this real quick. I'm going to disconnect. And then I'm going to turn my volume. Now my volume is not that high. My volume is reasonable. That's weird. Okay. Okay. Okay, so getting started in Python, hopefully. Yeah. Is it not shared? Sorry about that. Okay, are we good now? Okay. Yeah, I feel like this is doing way too many things at once for me. So I am sure I will drop some balls here. It'll probably get easier as we get a little more practice with doing both of these things at the same time. Okay, so Python. So welcome to your first lecture on Python. This is a very popular language right now for data science. There's lots of packages and lots of really useful code in Python. And we'll be using it for the lectures and the homeworks and for your projects. So you should have already installed Python and Jupyter Notebooks and Anaconda as part of your homework. So let's get started. Now with Python, we can kind of do it. We could just run it in the command line. So let me demonstrate that. So if I'm in the command line, I can just type Python, type it correctly. And it will just start running Python in the terminal. As you can see, it tells me what version of Python I have. And then I see this little triple arrow here, which is just a little command line prompt. You know, I can type something in. I can say 2 + 2. Python knows how to do that. Python knows that it's 4. Okay. And so we see, yeah, so you'll notice the symbol here. This prompt is different than if I were just in my terminal where I had the little % symbol. So this indicates that we are in what's called an interactive Python environment. And so there's 2 different ways that you can run it. Actually, there's 3 different ways that you can run it. But first of all, you can run it in interactive mode from the command line, or you can run it in batch mode, meaning you can just write a script that contains Python code in it, and then you can call that script and ask your computer to run it. But first, let's look at this interactive mode. So I can type a command. Let's say I want to print hello world. Okay, and what did I do? This was like the first command. I called the function print, and then I gave it an input, which was a string, hello world. Okay. So this is, yeah, if you've had other programming courses, you may know this is kind of a traditional first program to write. Maybe I shouldn't have done 2 + 2 before that, but oh well. Okay, so I think I said all this already. Right, this is, notice that when you do this, you have to put hello world in quotation marks. So that tells Python that it's a string. I could have used single quotation marks for that, right? Single quotes would be just fine. Let's try it. Okay, it still prints, but if I take them out all together, it's going to yell at me, okay, and give me a syntax error. Okay, and one observation, if you have ever coded in Python 2, you may be comfortable with this syntax, print space hello world, but that is not allowed anymore in Python 3, the version that we're working in. So we will need parentheses for all function calls to indicate what we're inputting into them. Okay, and now let's define our first variable. So here I can make a variable called my string variable. Are you still spinning? Okay, and so what have I done here? First of all, I've created a variable of type string, and then I've made an assignment and I've assigned a value, are you still spinning, to that variable. So one thing to notice is that a single equals sign is an assignment. So this equals right here is taking this thing and it's assigning it to that variable name. If you want to check for equality, that is a double equal sign. For example, I could say, how about I just say, are you spinning? And I call this my string variable 2 equals, are you spinning? And then I could check, are these things equal, using a double equal sign. Okay, and it says false. No, they are not equal because I changed the text. Okay, so the double equals will check a condition and return true or false. Okay. Okay, I think I said all that. Okay, and so I can also, just like I printed, I can now do the same thing that I did before, but calling the variable I just created. So if I say print, whoops, my string variable, are you still spinning? Notice here, I didn't have to put the quotation marks because this was already a variable of type string. So it knows that. Okay. And there are many different types of variables, not only strings, but of course we like to do math. And so we need numbers. And there's 3 different data types for numbers. They can be integers, they can be floats. Think, you know, any real number, infinite decimal expansion, not infinite because we're on a computer, but up to some fixed precision. Or complex numbers, which I really don't think you'll use it all in this course. And so you can get some more information on the data types there. But for example, let me make a variable a and assign it the value 3. So a equals 3 and a variable b, I can make that 2.5. I can take a and b and add them together and call that c. Okay, let's print c. 5.5. So notice the print command, you can also print a variable and it will just display the value of the variable here, which is 5.5 of a numerical variable is what I mean. Okay. Right. Notice though, what A was an integer, right? A was 3. B was not, it was a decimal, 2.5. And so that's going to mean that actually these got created as different data types inside Python. And if you don't know what data type your variable is, you can always ask. So if we do type A, we'll see that this variable is in the integer class. If we do type B, we'll see it's in the float class. Well, what's C gonna be? If you combine an integer and a float, it's gonna be a float, that's right. So that's a float. And then if we also look at, let me just say, actually, type my string variable, you'll see that that's type string. Okay, so it's important to keep this in mind as you're coding in Python. You can get errors, right, when you pass the wrong data type into certain functions. So be aware of, how every variable is of a certain type and think about how that will affect your code. Okay, so when we are done writing code in our little interactively in the terminal, we can just type exit to get out. And then we've killed the Python run. Okay, but another way that you can run Python is to write your code in a text file and then call it from the command line, Python, the name of that file, and it'll run, it'll execute it'll run that code in Python. So for example, inside the lecture folder, there's a file called, what's it called? First steps.py. .py indicates that it's a Python code file. And so where am I? I'm in, oh yeah, okay. So actually, maybe I won't take the time to navigate there because I don't think you're going to learn anything from that. But if you were inside the folder that had this file, you just type Python followed by the file name and it'll run it. And so here's the name of here's like the text that you'll see inside that file if you open it up. And if you run this Python name of the file, it'll output the output of that program. And we'll look more closely at this type of syntax as we go into Jupyter Notebooks. But take a look here, because we will be doing a lot of code like this, where we define a function in Python. So this Python code defines a function called double number. It has an input A. You can make comments with these number symbols to come out the code. And this right here actually says take A, multiply by 2, and then, well, A is equal to A times 2, essentially, that's shorthand for that, and then return that value. In Python, the indentation is very important. That's how it knows what's inside a function and what's not. So you'll notice after you define the name, there's this fixed indentation of 4 spaces, and all of the code for the function needs to be at that indentation. And then after we're done, we can print these things and see how they evaluated. Okay. Right. If you're going to be doing complicated things, though, if you're going to be writing longer code, longer scripts, running it interactively is not such a great idea. It's a little bit hard to work with, but it's good to know that you can do that. Okay, so you probably would either want to, write your code in a script, which you call, or as we'll see in Jupyter Notebook, where what's nice about that is you can just really see it, you can change things and run it. It's very easy to work with. And that's what we're gonna look at next, beyond running Python interactively and running it in batch mode, how we can actually run it in the browser with Jupyter Notebooks. Why don't we take, though, a 5-minute break, since we're about halfway through, we're probably a little over halfway through. Let's take a 5-minute break and come back at 4:27. For my Zoom people, is the volume okay? Any big issues?
No, I think you're good.
Thank you. Hi. Yeah.
Or
Okay, let's go ahead and get started. It's good that you're helping each other troubleshoot. So that's good. But let's take a few more minutes to go over Jupyter Notebooks together, and then we'll do breakout rooms and little groups, and you can work on some exercises together and also hopefully help each other get, any installation issues that you've had resolved. But this is this is probably maybe the most important of what we have done so far, which is how do you run Python in Jupyter Notebooks, because that's what we're going to be doing throughout the course in our lectures and our homework. And there's basically two different ways that you can run it. The first way I demonstrated in the beginning of class, right? When I opened up Anaconda and I clicked Jupyter Notebook, and then it took me into, let me just move this over to remind you. It took me into the browser where I can navigate to where I want to be, and I can open up any Jupyter Notebook. So the files with a .ipynb, right? Those are IPython files or Jupyter Notebook files. You can also start it from the command line if you want to. If you navigate into the folder where you want to be, and then you run Jupyter Notebook, it will do that same thing. It will just, it'll pop up your browser with that same window. So however you prefer to do it. I tend to like to open Anaconda Navigator and click the button because I have a little bit of terminal anxiety, but it's really just as easy to do it this way. Okay. So that's how we get started. And now that we're in here, you can see a Jupyter Notebook is comprised of different cells or blocks. And so let's get a little familiar here. So if I click on this, you'll notice it kind of changing where it's highlighted from one block to another block. So Jupyter Notebooks are made up of cells, and these cells can contain text or code. So we'll basically have two main cell types that we're working with: code cells, where we'll write Python code, and then markdown cells, where we'll put text, right? So if you want to write up some description, that's going to be a markdown cell where you write text. And so far, right, this was a text cell or a markdown cell, and so was this one. And if you double click it, you can see, kind of like the source code for the markdown. And there's different things that you can do. If you want to italicize a word, you can put little stars around it. That'll make it italics. If you want to make a word bold, you can put this double star around it. That'll make it bold. Okay. And then if I run this, so this cell is highlighted, if I run it, you'll see it displays really nicely. That word was made italic, that word was made bold. You can also include image files, okay? So here I have my data science cat. There are two types of people in this world: those who can extrapolate from incomplete data, and then, you have to, that seems like the kind of joke my kids would like, actually. But you can, so you can insert these images with this little exclamation point. Then you write the name of the caption, like how you want it to appear. And then you write the file name. Now, remember, any image file needs to be in the same subfolder where the Jupyter Notebook is, or it won't know where to find it. Okay. So let me go ahead and. Okay. Right. So this Jupyter Notebook, it really kind of saves everything, the input and the output, as you edit in your browser. It's written into this file. And so for your homeworks, you will write in, homework 1 dot IPY and B. Again, if you're doing this in Git, you might want to put your name on it so it makes a different file. And so you'll start with the template, which basically has the questions in there, and then you'll go in there and you'll add cells with your code and maybe cells with some explanation. And then you'll, take the template with the questions, you add your cells with the answers, and then you'll zip it and submit that on Canvas. Okay, and another option is Google Colab. I'm not going to go into this a whole lot, but somebody was asking me before class, oh, if I didn't get Anaconda installed, can I still run stuff? And Google Colab is a way that you can, to do Jupyter Notebooks, you have to have Anaconda installed, you have to have, all of the software installed to run it. But Google Colab actually runs in the browser, so you don't have to have the software locally installed on your machine. So you can check that out if you want. We do recommend, though, for the lectures and the homeworks that you do it in Jupyter Notebooks where you have the software installed locally. But for your projects, that might be a tool that you want to explore because it's good for collaboration, like people changing things simultaneously. Okay.
So is that for the homework, we just grab that homework one and rename it, and then we can submit that file?
That's right. Although if you're not doing the Git with it, then it, it's fine. Like if you're just going to re-download the repo to get the next homework, then you wouldn't need to worry about that. But yeah, if you're doing a Git pull in the same folder where you're working on stuff, then rename it. Okay. And so what's cool about Jupyter Notebooks is that you can actually write code inside the cells. And you can do different languages for that, but we'll use Python. Okay, so you can see again, that was like a little text cell, but now this is the first code cell in the notebook. And inside these code cells, you can write Python code. And when you run it, it'll execute just like a Python program. Okay, so here, print hello world, a equals 3. You can comment things out again with the number symbol. And the cell is always going to output the last line that's in the cell. And so you'll see if I run the cell, it prints hello world, and then it outputs 3 because that was the last line. Okay. And the output is now directly written into the notebook. So it's like saved there in the notebook. And so you can change something in a cell and you can rerun it, right? I can say A is 5. And now I rerun it. I've changed the value of the variable. So that's fine. There's a shortcut for this too. If you don't want to, if you feel like going up to click the run button is too cumbersome, you can just hit Command Enter on a Mac or Control Enter otherwise, and that will just do it automatically. Okay, so another cool thing is that the cells preserve the state of what happened before. So for example, I'm going to do a new code cell. I'm going to run this, and I've initialized a number of variables. Age is 2, gender is female, name data science cat, smart equals true. So I've defined 4 different variables. Now, if I go to the next cell and I run this little code snippet, it knows what I mean by these variables, right? So these variables and the values that they have are remembered in the next cell. So you can write, code kind of as if it's like one long, program, if you like. It remembers the variables that are sort of like in your workspace. Okay. And so this behavior is different than if you were to execute the contents of the cells in sequence in a Python file, right? For example, if I say A is 5, and I run that, right? I've changed the value of A. And so if I go up here and I add A, it knows that it's 5, even though in the notebook, that assignment was further down. Because I ran it, it keeps track of that value of the variable. So things can get a little bit mixed up if you're not careful in remembering the order in which you define things, but we'll show a check that you should always do before you submit your homework. Okay, so let me see what else I wanted to say about this. Yeah, let me get rid of this now. Okay, so here, oh yeah, and let me point out that there is the cell menu up here. You can also batch execute multiple cells with the cell menu. You can run cells below, run cells above, etc. And here you can also change the type of a cell from a code cell to a markdown cell. So that's helpful. Okay, and so in this command, we've called the print function, which we're familiar with, and then we've used this plus symbol. That's a concatenation. So it's taking all these different strings. Some of them are variables, which are strings, and some of them are strings, which we've just typed out, and it's concatenating them together, right? So the string variable concatenated with this typed out string concatenated with the age variable, which is a number converted to a string. So we had to apply the str function for that, etc. Plus a Boolean, which is smart equals true. Okay, if you don't have the str there around age, it will throw an error. But there's other ways that you can essentially accomplish the same thing, that you can use the print command. So for example, I could also print name. So I'm going to print that variable, which is data science cat. And then this says, now go to a new line. So that just means new line. And then print this text string age, followed by the value of the variable age. So age 2. New line, gender, which is a string variable, right? Female, new line, and then this text followed by smart, which is a Boolean variable. So you get all the same information. Okay, when you're working inside a Jupyter Notebook, there's 2 modes. There's what's called command mode and edit mode. You can see which mode you're in by the color of the cell. So notice it's blue here, right? But if I start to type something, it turns to green, it turns to edit mode. Okay. So when you're actually making edits, it will turn green. But otherwise, if you just highlight it, it will be blue and it will be in command mode. And so many operations and keyboard shortcuts depend on what mode you're in. So there's some keyboard shortcuts. They're only going to work if your cell is blue, if it's not in edit mode, but it's in command mode. And you can kind of switch in between with the enter and the escape command. So hold on. So like if I go in here and I, sorry. Right, so for code cells, I think it's also markdown cells. You can switch into edit mode with enter and get out of it with escape. But yeah, so here I'm in a code cell, and I'm in command mode, if I want to go into edit mode, I can hit enter, and that makes it green. And now I'm in edit mode. If I want to get out of it, I can escape and I'm back to command mode. Okay, so here are a bunch of shortcuts that may be helpful to keep in mind. Most of this you can do, just with the little menu. Like if you prefer to work that way, you can add a cell with this little plus button. You can delete a cell with this little scissors sign. You can run with the run button. So most of these things you can do with the menu, but if you want to speed things up with the keyboard shortcuts, Command Enter runs the current cell, or Control Enter on Windows. So if I'm here and I want to do Command Enter, it'll run the cell. Shift Enter runs the current cell and jumps to the next cell, right? So if I'm up here and I do Shift Enter, notice it's going to go down a cell, Shift Enter, go down a cell. Also, Option Enter runs the cells and adds a new cell below it. So if I do that, right, it creates a new cell underneath where I am. And then if you are in command mode, so you have to be inside of a blue cell. If you're inside of a blue cell, you can do all of these little things. H shows the help menu. So let me do that. So if I do H, here's your little cheat sheet, right? If you can't remember these things, you just do H and it'll bring up all of these shortcuts. Okay, A adds a cell before the current cell, B adds a cell after the current cell, DD deletes. M is Markdown and Y is Python. That will allow you to switch the type of a cell. Okay, so right now I'm in a Markdown cell and I'm in command mode. So if I hit Y, it switches, not a great idea because this is not code, but it'll attempt to switch it into a code cell. And then to get it back into Markdown, I need an M. Okay. Okay, so just play around with that, just work through the notebook and just try it yourself so that you're comfortable with it. Another thing to be aware of is what's called the kernel. So when you run code, the code is executed in a kernel, and you can do bad things to it. So you can, yeah, question? Oh, what's that?
Revoke your like if I delete a cell or carry.
Oh, like an undo? That would be useful, wouldn't it? I just tried that. I don't know. Let's see. Okay, so here's one that says undo. I actually haven't used that, but I think that should work fine. So try it out. Does that work? Okay. It's really, really the most useful command ever. So you would hope that that's available to you, and it is. Okay, other questions? Okay, right, so sometimes if you I don't know, write something weird and it goes into an endless loop or things just go wrong, you just want to start everything over again. And so it's helpful to be aware of this kernel menu up here. You can restart your kernel. And one thing that we will ask you to do before you submit your homework is to restart and run all. So that's going to restart everything, run everything from start to finish. Then you can make sure that you didn't, define something here that you used up there. Make sure that you have everything in a good working order and that there are no errors, right? So I'll just demo that, right? So I can do that, restart and run all. And you'll notice when I did that in this cell, it contains all of the output. So by default, when you do that, it's going to also show the output of every single code cell. If you don't want that, you can restart and clear output. and then you won't see all that stuff. But for your homework, you should restart and run all and have all of the output displaying in the file. Okay. So, oops. Sorry, I got ahead of myself. Okay, restart and run out, storing output. Right, so like I said, the notebook is going to store both the input and the output. That's actually pretty handy. It is, however, stored in a bit of an ugly format, which makes version control on these things rather difficult, but oh well. Okay, so let's move into some Python basics. We already did a few basics, but let's talk a little bit more about functions. Everybody seen functions before in math class, right? So function takes an input, gives you an output, something like f of x equals x squared plus 3. Sometimes in programming, functions are called subroutines or other names, but they're really helpful for structuring and modularizing code. Oh, often called procedures or methods. Okay, so the syntax that you want to use for this, like we touched on earlier, you always do def when you're defining a function. So def, and then whatever you want to call the function. Here we're just giving it the name f, not a very descriptive name, but that's what we're doing. And then we're indicating all of the inputs in here. And then we're creating a variable which squares the input, adds 3, and then the function returns that variable. Okay, so let me run this. Okay, so we can now run this function with multiple different input values. Okay, so print f of 2, print f of 3, f of 5, and you can see it's working just as you expect, doing those computations and returning those values. But okay, one thing, yeah, I've already said that. For good practice.
What is it? How to, what does that mean?
What does this out to mean?
Yeah, what is that?
So that's the output of that cell. And the output is going to be the, everything that's output by executing that cell. Does that kind of make sense?
Yeah, so I took you out to go to 28. Yeah.
Yeah, so it's all of those things. Yeah, not just the 28, but the, yes, everything that was output when you ran this little program. And like I said, it's always going to output the last line, even if you didn't say print. But the other ones it won't. So for example, if I remove the print from around this one, then this is not going to be included in the output. Hold on, let me zoom out a little so I can get my run button back. Right, so in this case, you're seeing the 7 because we said print f of 2, but it's not going to display anything in the middle that you don't say print, but it will display the last thing. I'm not sure why, just how it works. Okay, so do use descriptive function names when possible, because that will help you remember what they do. So square plus 3 would be a better name for that one. And we can have many different inputs to the function. So we can define a function f of x, y, z. And then the parameters are then available as local variables, but only inside the function. So that's an important concept, that whatever these things are, they're local variables inside the function. I'm sorry, I should not have said that. These things are your input, and then it's defining a variable, which is the result of the function, which is a local variable inside your function. Okay, so, and then the third line, so we define the function, we create this variable, and then we return it. And so this variable result is a local variable inside the function. Okay. So how much time do I have? I don't have a whole lot of time. We're not going to have a whole lot of group time today. Okay, so again, the indentation is important. So you need to indent it by 4 spaces. And you'll notice if I defined it like this, and then I don't have this last line of the function indented, and I run this. Okay, if I run this, it's going to give me a syntax error because that bottom line is not indented correctly. And similarly, if it's overly indented, it's also going to give me a syntax error. So I need everything indented by 4 spaces inside the function. Okay, and so one thing to keep in mind, right, is that variables that are defined inside of your function are not available outside of your function. And if you try to call them outside of your function, you'll get an error because they only live inside of the function. So for example, here, if I am inside a function and I define this variable function scope, only readable in here, but then I try to call it, no, well, here it's fine, because I'm just calling the function. So this code should be fine. It's just printing this variable. But if, on the other hand, I'm in the next cell, or I could have been in the cell further up, but I tried to call this variable, which was defined inside the function, but I'm outside the function, that's going to give me an error, right? So these variables are only defined inside the function. Okay, and so you may wonder, why is that? Isn't that annoying? If I defined it up there, shouldn't it know that I may want to use it later? But it's actually a really bad idea to make variables. I mean, there may be some reasons for it, but in general, you don't want variables to be global. You want them only to be local inside your function. You can make them global if you want, but you probably shouldn't, because it's basically the whole reason for to modularize code. You have to have local variables, and otherwise you would get all kinds of errors when you try to run other people's code. Okay. However, you can define a variable outside of a function and use it inside of a function. That's okay. So right here, I've defined a variable outside of my function, and then I reference it inside my function, and that's going to run fine. It's not generally a good practice because it would be better in this case to define a function that takes name as an input and actually run it as a function calling the input name. So in this case, if I run this, I'm going to get the same effect, but it's a little bit cleaner to make the dependence explicit, right? So if your function is depending on something, you want to make that explicit. Okay. Yeah, and then what I said is you can make a variable global if you want, right? So here you can make that a global variable, and then if you call it later, you won't get an error, but it's not recommended that you ever do that. So, okay. Okay, great. So looking ahead, next week, we'll go more in depth into Python, looking at conditions, loops, advanced data types. And I'm sorry that we kind of ran out of time for group time, but I encourage you to just try the exercises that are in there for practice. It's just, just basic stuff that we talked about today, working in a Jupyter notebook, writing a function, and just getting comfortable with that. And you guys are welcome to stay and work on it together. I'm great with that, but I don't expect you to, since it's already 4:57. So. Yeah, so how it works is we're going to be doing these exercises in a lot of different classes, and you only need 5 of them. So you don't have to do any specific one, but by the end of the semester, you want to have done 5 of them. 5 exercises. And so we may have 10 over the course of the semester or something like that. And these are not graded because they're just for your learning. And so if you just attempt it and submit something, you will get, participation credit. So these are just to help you kind of process and interact with the lecture. I'm sorry, I can't hear you very well. Oh, so, okay. So inside the lecture folder, there's an exercises file with a couple of different questions in it. So check it out. And what I'm saying is that over the course of the semester, we're going to have that, multiple times. And at least you need to submit a file for at least 5 of the lectures. But it doesn't have to be this one. It can be a different one. Yeah, it's a little confusing, but in Canvas, you'll see activity 1, activity 2 through 5, and you just need to submit 1. I mean, 5 by the end of the semester. Ooh. Yeah, that's easier. Let me just check in with my Zoom people to see if. Okay, do I have any questions from the Zoom people before we end class?
Yeah, I have a question. And on the activities in Canvas, it says we need to submit a PDF or a zip. So I guess, do we just, but like the exercises is a Python file. So do we need to like convert it to a PDF, or I'm confused about how to submit that?
Oh yeah, it shouldn't be a PDF. It should be a zip of the Jupyter notebook. Sorry.
Okay. All right. So yeah, zip of the, okay, that makes sense though. Okay.
I have a question. So, I went in and maybe this is besides the point of today, but I went in and I created like a new Jupyter notebook, and I'm wondering where does that live? Like when I create a new one.
Okay, sorry, I just disconnected that because the volume was so loud.
Oh, that's right. Sorry.
No, it's not your fault. It's been happening the whole lecture, and I don't know because my volume was not set very high on my laptop, so I don't know why that was coming through so loud. Maybe it's the volume set in the room.
So I created a new Jupyter notebook, and from the URL in the browser, it looks like it's like opened it up in homework 0 folder or
so how did you create it?
I went to so I had opened basic Python, the Jupyter notebook, and then I went up to file and I did new notebook, but that was probably wrong.
Oh, no, so that's okay. So you're saying, hold on. You're kind of asking what directory it gets put in?
Yeah, where does it live then? Yeah, what directory?
Yeah, good question. So I believe that depends on where you are when you launch Anaconda, right?
Yeah.
So
Oh,
you still see my screen?
yeah, no, not anymore.
Not anymore. Let me share my screen for a second. Maybe we can go. Okay. Okay. Right. So here, I launched Anaconda basically just from my home directory, and then I navigated into the folder that I wanted. But if I'm here and I make a new one, I'm assuming it's just going to put it in whatever directory that I'm in already.
Okay, and then is there like a,
right? So if I do that, but I can always move it, move it around just like any other file. But, if I create this here and I call this test, right? Rename. Now, I think it should show up here in my, yeah, so it just put it in that same folder where I created it. So,
okay,
yeah, depending on where you want it to go, navigate there and create it, or, just you can drag it around in your Finder too.
okay, thank you, that makes sense, thanks.
No problem. Okay, any other questions on Zoom?
Yeah, can I just ask a quick question about homework 1?
About homework 1?
Yeah, so on some of the test functions that you have in there are named, like you have a test function for, I can't remember the names of the functions, but like one of the functions is print reverse. So just, you reverse the list. And then a little bit later, there's another function that says reverse comprehension.
Okay.
What is the comprehensive and comprehension function supposed to do?
You know what? I would have to open up the homework to refresh my brain on exactly those functions, etc. Maybe can you create a question in Piazza about that?
Yeah, sounds good.
Okay. I'm sorry, I don't know off the top of my head. I need
No
I need to look back over it again.
It's all good. Thank you.
Okay. Okay, I've got a couple people waiting in person, so let me switch to them and then I'll check back in with anybody who's left.
Okay, so this is where I'm confused with the exercise. That's what we're talking about. So for example, it says exercises for lecture 2, and we would enter code. So do we have to do the 5 of them? I don't know.
Yeah, that's what I said.
I don't know why it's
Yeah, I
so
mean, it's
confusing.
totally.
Oh, yeah, so this is like a little confusing because it's exercise 2, 3, and 4. Is that what's confusing?
Yeah.
But it's all one exercise.
Oh,
Okay.
it's all one
So
exercise.
maybe just think of this as like problem 1, 2, 3.
Oh, okay.
But this is like one exercises assignment.
Okay, so we're gonna, so throughout this semester, we're gonna do like 15 of these big, okay, so.
I don't think there's gonna
or
be
10 of
maybe
them.
10, yeah.
But out of those 10 that we did throughout the semester, we're just, for example, if I just completed this one, this will count as 1.
That's right.
And then 3 lectures, and then we'll do like 2, 3, and then I do 4, and then I submit 4, that'll count as 1, 2.
That's right. But
So, okay, so each one, so whatever, so this is exercises for lecture 2, this will count as 1.
yeah, that'll count as 1. And so in Canvas, you'll see activity 1, 2, 3, 4, 5, but they don't have to match up with certain lecture days, right?
Okay.
Because if you don't turn in this one for activity 1, but you do one for lecture 4, then you can upload that into activity.
So as long as we submit 5 of these totals, then we'll be fine.
Yes,
Okay.
that's right. And again,
Alright.
these are really just for your learning. We want you to
Yeah.
try them to make sure that you're, that it's clicking.
Okay. No, that makes
But we're
sense.
not gonna like, check, we're gonna read it. We'll
But
just
then,
see if we submit it.
for some reason, I ended up in-
Oh, yes, so here, you're actually not in code mode, you just need to run the cell. And then it'll like, it'll show you the output of that markdown.
And then to change it, we did the, if it's in here, it's a code. One of them will change to code, and one will change to this. All right, so.
And then for this text cells, you can just double click it to go in and edit it.
Oh,
Yeah,
and then once I'm done, it's just,
that's right.
okay, cool. So then with this activity, we will do some over the class, but we don't have to submit it right.
That's right. So if you're going to or to get like participation, lecture participation, I think you're supposed to submit it like sometime today. Maybe we should change that since it's like classes and this is finishing up.
If it's success, if it's something you submit by 6.
Yeah. Yeah, so what you can, it's not, there aren't like due dates on them in Canvas because you can kind of submit it throughout. So aim to submit it on the day of, but.
Okay.
But actually, let me talk today about this, but I'm thinking, given our class, we just started today, we should have it till the next day. So,
Yeah, that makes a little kind of because I'm not such a fast, it takes me a while to kind of sit for stuff.
yeah, I think
So
that's
we have a little bit. But we'll be working on it throughout the class and then we basically try to finish them off on our
the
own.
idea is that you just do it in class and then you just upload it.
Yeah,
So what
makes
happens
sense.
is that I go slow and you
Oh,
take
it's
the time and then, yeah, and then you do it afterwards.
Well, this makes more sense.
Okay, no problem.
I have downloaded the Python 3, but the default version is still Python 2 in my terminal. So how could I check my version Python in my
Okay, so somebody else had this same question. Can you, when you go to Anaconda, does it show that you're?
No, it's no kind of, it's another another version. No.
Okay, so it looks like you don't have Anaconda installed. Do you have Anaconda installed?
I install this.
You do have it. Okay, so you do have it. If you go to your environments and you look at the Python version, what is it? Sim.
Comment?
Well, I was thinking Python, like it should show you the version of Python that Anaconda is running.
The Python that you use, we're not really-
Mhm.
It's really noisy compared to Jupyter, but
Yeah. 3.9.
So I,
It's a 3.9, but it's a 3.2.
okay, yes. Oh, your terminal is 2. I thought you said it was 2.7.
Yeah, 2.7. The terminal default version is 3.7. When I just type the Python, but then if I type Python 3, I'm gonna take Python 3.
Yeah.
It's,
I believe, sorry, not to interrupt,
yeah.
but just, I believe that Anaconda does not support Python 3.10 yet. I think Anaconda only has released up to 3.9. So that's what you want to go with.
So I have to
I think,
uninstall Python and
no,
restart.
I think you're fine because this is saying that Anaconda is using Python 3.97. So if you're running this in Anaconda, it should be fine.
Okay, so it's okay.
Yeah. Mhm.
And another thing is it looks like I need to install something Python, but I will use something.
Are you able to run the notebooks?
Yeah. How? Like, yeah, it works.
Okay, so you have at least some version of IPython installed, or you wouldn't?
Okay, so
Run.
everything is fine, right?
I think so.
Okay, cool.
I think it's okay.
Yeah, thank you.
No problem.
So I'm not yet a student of the class, but I'm thinking of signing up. It seems like it's pretty similar to 3170 applied statistics. Am I correct in that? No.
I have not taught 3170,
Okay.
but that's applied statistics. But my guess is it's going to be fairly different
Okay.
in terms of a bit more programming and computational stuff.
Right.
There will be some overlap,
Yeah.
like on the
Right,
statistical
right.
side and some of those tools.
Mhm.
But I do think and again, I haven't taught that course.
Right.
But my guess would be there'd be a good bit that's not covered in that course.
Okay, and are you at all familiar with the computer science minor here at the?
Not very,
Not very.
but you know,
Enough
I can try to
maybe
answer a question.
Right, so I'm doing a math and computer science, like a math major, computer science minor. So do you think taking this class would be too repetitive if I do the minor as well? Because they do cover a lot of similar stuff.
Okay, so in turn, you know, that would probably be, Bay would probably be a better person to ask because
Who's that?
she's my co-instructor.
Okay,
So because she's from the CS department.
okay.
And she'll have a better idea of what's covered in the CS courses
Mhm.
and if there's redundancy there or not.
Right,
So yeah, maybe reach out to her and get
Okay.
her opinion.
okay,
Yeah, on the math side, we don't really have other courses that cover this.
okay,
So it's a good one to take. On
right,
the CS side, if you're doing a CS minor, I'm not sure how much overlap is covered in other
Right.
courses.
right, okay. I appreciate it.
Yeah.
Thank you.
Uh-huh.
I was just wondering.
Oh, yeah, I'm sorry, real quick. Let me just double check because
No, I can keep waiting. I'm just at home. You can answer everybody's question who's in line.
thank you. Thank you for your flexibility. Okay.
I was just wondering for the homework, what we were supposed to like turn in. I didn't know exactly like what, yeah, for homework 0, because, I was looking at them and they look like the same, the lectures and homework were the same on my side. Like when I open up homework 0, all of this is here. And then I just did the exercises here. And then from the lecture, it's like the same files and everything. So I wasn't sure if like maybe I like downloaded it wrong or something, because yeah, this is what I'm getting for like, this one is the homework. And then this one's like the lecture. And I wasn't sure if maybe I was, like I downloaded something wrong or
So
if they
can
are
you
the
show me
same.
where are you storing all this on your computer?
Yeah, so they're just down here. I have the lectures and homeworks.
Perfect.
And then I opened this guy up. Let me see. And then I wasn't sure if they just wanted this like file or just everything all.
Oh, so what happened here is we just added that. So there's duplicates. We
Mhm.
just added the files from this lecture. I think because homework 0 asks you to try.
Yeah.
And we didn't know if we'd have that lecture uploaded yet onto the lectures repository. So we just wanted you to have something to test, that you could
Okay.
open a Jupyter notebook. So that's why that stuff is in homework 0, but there's nothing you need to turn in for homework
Oh,
0.
okay.
It's just to make sure that you're set
Everything's
up.
like set up. Okay. And
Mhm.
then I just did have like a question on this guy. I think it was, I was wondering if like you have to define these functions. I don't remember where I heard it, but like I thought that all of this like computation stuff had to happen above, and then you put all your functions at like the bottom. But I don't know if that's like if I moved all of this before the function, would it still work? Do you know if like
So it wouldn't work the first time.
mhm,
Like if this was the first time you had written it
mhm.
and you called these things before you defined the function, then I believe it would throw you an error.
Okay.
However, if you define it here and then you go up here and you create a new cell and you
Mhm.
reference it, if you've already evaluated that cell, it already
It'll, like,
knows what
save
that
it.
function is.
Okay.
So it kind of depends.
Okay, okay. Yeah, that makes more sense. I was just confused on that mostly, but, okay, thank you.
Yeah, you're welcome.
Yeah.
Hi.
Just have a question on, does it really matter if we like download like dependencies on the computer or just like using like those images instead of downloading like Python, we had Anaconda, maybe that would be good for the rest of the semester if I don't want to like download all that onto the computer.
Sorry, if you don't want to download like
With the Python, Anaconda and all that, but just like using the like a Docker for something, just getting an image and using like that kind of like the virtual instance of Python and Anaconda.
I see. Well, you know, we recommend that you have it installed locally, the Anaconda and the Python, that you're, yeah, like running that on your notebook, were you having, I mean, were you having issues with installation or a reason that you're having trouble?
My computer, I use my Mac, it's broken, so I had my iPad and I checked out a computer from where the library, and so I just pulled it from I think to get like Docker and stuff. I didn't want to install everything else, so I kind of just like created a so I could have Python and the Anaconda and like my own environment to work. And
Yeah, that might be fine. I have not done it in that format, so I'm not quite sure, you know, if there are any issues that would arise. But you know, maybe you can try it and see if there are any issues, and then hopefully, do you think your computer will be fixed? Okay, right. So hopefully won't be like, yeah, if you can get through the first homework or two and the lectures. Yeah, so is that kind of like a remote desktop thing or no?
No, it's like it's like I think images inside like whatever the Docker thing that we have that has instances of like Python and all that. So if you're able to like pull them from like the Docker library, because people can upload it and do the like run like Linux too there, but you don't have a Linux machine, you kind of just do it there. But it's all on the local computer, so it's using everything from the computer, but it's pulling from somewhere else. So it just not I have like I would if Python's not really installed on the computer, but it lets me run Python and use the terminal from there.
Yeah, so I mean, yeah, I guess I don't know, unfortunately, if you're going to run into any issues doing that or not, but you could give it a shot. Otherwise, you know, there's probably like computers at the library and stuff, but I know that's not so convenient.
Yeah, I tried doing that because like the Python installed there and trying to install and I got there need my other administrative privileges. We need to see the privileges in there, like you get that. So that's why I just tried going to that way.
Okay. Well, maybe you can try like seeing if you can do, you know, the exercises. That would be a good place to test it out. And
I was able to do too, right? So,
okay, good. I mean, another thing you could look at Google Colab too, because that's all browser based. So you don't need anything installed for that. I haven't really used that in the past, so I'm not exactly sure if you can like, probably there's a way to maybe like export from Google Colab into a Jupyter Notebook. And
it lets me run the Jupyter Notebook on like the from Docker image and using the data science notebook from Jupyter. So that's me getting there. But I think you just have to like push the thing back to GitHub, but I'm not sure. Do we need to have the repository private?
You're not going to push anything to the repositories. You will just, you know, download or clone the repositories and then do it and then upload to Canvas.
Oh, but like if you have your own repository outside, like from the class one, but then there's a different one that's you've already cloned into your own workspace. So if you like, maybe if you already mentioned my repository, my work would be there from the past, like from the assignments. Like that, but I need to have that private, or it does not really matter, because I think if you are able to get into there, you can kind of see what I've done.
Yeah, so I won't be able like to see that. Yeah. You mean like if you like clone the repository and then you like work on stuff, right? But you can't commit anything to that repository. So none of the teaching staff would like have access to it unless you submit it separately.
Just like more. Oh, so you guys only have it, right, because it would push to your that repo.
Yeah, you cannot push to the repo. So we will not see anything that you do on it. That's right. Yeah, because it's yeah, you don't have access to make changes there.
Good.
Okay, maybe I should check on my Zoom person if they're still there. But yeah, let us know if you have issues and we'll work something out. So, okay. Okay, are you still there? Do you still have-
Yeah, I'm still here.
Okay, sorry about that.
Yeah, no worries. So I just had a question. I think I was having a hard time hearing what you said to one of the other students, but do we have to submit the practice exercises for today's lecture?
Okay, so you can, but you don't have to. Basically, if you go on Canvas, you'll see like 5 activity slots, you know, like 1, 2, 3, 4, 5. And we're going to be doing exercises just for practice with a handful of lectures, probably 10 or so. So you just need to submit like 5 of them by the end of the semester, but you don't have to submit every one. And they're more just like to help your learning and for course participation. So they're not graded. It's just like you get credit for doing it.
Okay, thanks. That makes sense. And this question might not relate super much to today's topics, but if I'm doing clustering on a data set that has mixed numerical and categorical data, do I have to do 2 separate clusters on the numerical and categorical, or can I do it like all in one step?
Oh, okay. So that's a great question. Like, how do you kind of integrate your categorical and your numeric features like together?
Yes.
Yeah, it could depend on what exactly your categorical ones are. You know, for example, if it's like male and female, you could just make that like 0 and 1, and that would probably be fine. But if you have 5 categories, but they don't necessarily have an order to them, you're going to get into trouble, right? If you make them
right
1, 2, 3, 4, 5. So you have to think a little carefully about what you do. I'd probably need to, you know, need to know a little more detail about exactly what the data was to be able to give a great answer.
Okay, no worries.
Yeah.
Okay,
But
thanks.
I will say you do want to integrate things. Like you don't want to, yeah.
Okay. Okay, thank you.
Okay, no problem. Take care.
Yep, you too.